In the first video, we are going to recall our understanding about the discrete time impulse sequence. The discrete time impulse sequence is also known as Kronecker delta function, and it is a simple function compared to the continuous time counterpart. We know that in continuous time impulse signal, we have defined it as the area of the impulse signal is 1. When the width of the signal is becoming narrower and narrower, the signal amplitude will go to infinity. But in the case of discrete time signals, we cannot say something about area because the signal itself is a value at a particular point. We are sampling the continuous time signal at a particular point to get the discrete time sequences or discrete time signals. In this case, we cannot talk about area because that is a single point, that is a single value in the time axis at a particular time. These are the amplitude values of the continuous time signal at discrete time intervals. So we cannot talk about area here. So the discrete time impulse sequence or discrete time impulse signal is defined in a simple way. That is, the height or the value of the discrete time impulse, normally we denote using delta of n equal to 1 at n is equal to 0. That means at 0th time instant, the value of that function or the value of that signal is 1 and it is 0 everywhere in the negative time axis, and in the positive time axis its value is 0. Now when we give this signal into a system, it will produce some kind of output that is known as the impulse response. This impulse response is very important topic because we can characterize an entire system using this impulse response. That is what we are going to discuss in the upcoming videos. So this is a very important concept. People have a wrong understanding that we give impulse and the impulse response we will get that will last only for that time instant. That is a wrong understanding all the students are having when they study signals and system. Please keep in mind that even though the impulse is a very short duration signal, it is happening only at n is equal to 0, the impulse response may go beyond that. It may last for longer time. For example, in the previous video series, I have explained it using the firework and smoke. Even though the firework or the matchstick is only for a small moment, the effect, the smoke will remain in the atmosphere for a longer time. So in that analogy, you have to consider this impulse and impulse response. Even though impulse is occurring only for a small time, the impulse response may last for longer than the impulse, right? It may go some more time. Sometimes it may go to infinity also. That is also possible. That thing you have to keep in your mind. Now let us go into the video and recall what is the concept of discrete time impulse signal and what is the concept of impulse response. Now let us learn the basic impulse and its response known as impulse response. We have already studied about impulse signal. The impulse signal is defined like this. In the case of discrete time impulse signal, so we will write like this: delta of square bracket n. The square bracket indicates that it is a digital signal or a sequence, and n is the time index. N is the time index. We have already learned about this when we are talking about operations on signals. And unlike the continuous time counterpart, here it is defined as value is 1 for n is equal to 0 and the value is 0 for n not is equal to 0. In the case of continuous time impulse signal, we are defining the impulse signal's area as 1, but here its height is 1. You can see that this is the very famous impulse discrete time impulse signal. You can see that its height is 1. Okay, so it is to be noted that it is not the area, height is 1, right? Now one advantage is that we can delay or advance this impulse signal and we can change the position of this impulse to wherever we want. For example, here you can see the index value of n. Here n is equal to m. In that case, if you write del of n minus m, what happens is that our impulse will move to a location m. Impulse will move to a location m. Here it is minus m, n minus m, so it is a delay. Actually it is a delay. If suppose our impulse is here, somewhere here, it is minus 1, it is minus 2, it is minus 3, we have to write del of n plus 3. So this is the 3 location, and what happened here is advanced. The signal is advanced. So this is the basic idea of discrete time impulse signal. Now what are impulse response? Impulse response are most important in the case of convolution. Whenever we provide this impulse signal del of n into a discrete time system, please note that we are talking about discrete time system here, and del of n is a discrete time impulse sequence, and when we give to a discrete time system, it will produce h of n, and h of n is nothing but our impulse response. So we know that this is a discrete time system, so the impulse response is also a discrete time signal. It may look something like this, right? So don't think that the discrete time impulse response will be always look like this. It will vary from system to system, right? So the impulse response is characterizing the system's behavior or the system's response. So it is purely depending on the system, and it will vary from one system to the other. For example, if you try to beat somebody, maybe your friends, beating is an example of an impulse, and how they will react, that is known as the impulse response. You know that when we beat somebody, some people may smile and some people may get angry, some people may beat us back, right? So we cannot predict it. So the impulse response will vary from system to system. One of the main misunderstanding among the students is that since impulse is appearing only at n is equal to 0, the impulse response also will appear only at n is equal to 0. That is a wrong understanding. Actually, the impulse response is a signal which may last longer than that. For example, even though the delta n is only at n is equal to 0, this is n is equal to 0. Actually, we are giving only a signal, the impulse only at the location n is equal to 0. The response may go beyond that, right? The response may go beyond that. So I have already explained this in the case of firework and smoke. The firework may go or die out very fast, so it is a shock, but the smoke will remain in the atmosphere. If somebody beat you, the beat is a sudden shock, but the pain will remain in your body. Likewise, the impulse response may remain for longer time. That is based on the system, and for some system h of n may go to infinity, right? So there are some systems for which the impulse response may go to infinity. So these are the 2 points you have to keep in your mind. The impulse is a signal which is defined only at n is equal to 0, and its value is 1. Its height is 1, and we can delay it or we can advance it, and we can move the position of the impulse signal wherever we want. And the impulse response is a response obtained from a system when we give del of n as the input, and it is not a shock kind of signal. It may last longer than that, right? It can go for a longer time and it can die out. Then maybe sometimes it will be a shorter signal and it will die out very fast. So it is depending on the system. It is based on the system, and this h of n can be used to characterize the entire behavior of the system. That is what we are going to discuss in the next video. I hope you got a clear idea about discrete time impulse function and impulse response. These are the building blocks of this video series, so I hope it is clear.